Hello and welcome to this video where we're going to solve a Pure Maths 3 past paper from February-March 2023. Okay, let's get started with the first question. Express y in terms of x, so the first step I'm going to take is to combine the two logs on the right-hand side using this property of logs. Log a over b would be log a take away log b. And I will have to use it from right to left. Now, how can I get rid of the log on the right-hand side? I'm going to raise e to the power of the left-hand side and the power of the right-hand side. So now on the right-hand side, e and natural log will cancel each other, and we are left with 2y minus 3 over y plus 4. Now I'm going to get rid of the fractions on the right side and multiply by y plus 4. Now expand the brackets. Now I want to collect all y's on the left side. That means these 2y will go on the left with a negative sign, and 4 e to the power of x will go to the right side. And I will also change plus to minus. Now, how can I make y the subject? First, I will have to factorize and bring it out of the bracket. And now let's divide everything by e to the power of x minus 2. Now, technically we're done, but there's too many minus signs. So what I want to do is to multiply top and bottom of the fraction by -1. That looks way much better. Question 2 is about complex numbers. And first of all, let's take minus outside of the brackets. Now we have to draw the locus of all complex numbers with the argument in between -1 over 3, pi and pi over 3. That's going to be a half line with the center 1 plus 2i. X-axis is going to be the real part, and imaginary is going to be y-axis, 0 here. So 1 plus 2i is going to be 1 on the real axis, 2 on imaginary. Now, argument is the angle from the horizontal. It goes from minus pi over 3, which is negative 60 degrees, so this way, approximately, and plus 60. Now, we also know that the real part should be less or equal than 3. Oh, actually, I should have drawn the solid lines because of the inequality sign. Okay, so 3 on real axis is approximately here. And now that's our region. Next question, calculate the least value of argument z for points in the region from question A. So the point with the least argument is going to be right here. That means we're looking for this angle. Now, how can we possibly find this angle? I want to focus on the two triangles. The red one, and the second triangle is going to be green. What I want to do now is to find this length from the green triangle. We know that this side is 2, because 3 minus 1, and we also know that this angle is pi over 3. The question mark is the opposite side, and this one is adjacent. So that means we can use tangent and say tangent pi over 3 is equal to the question mark over adjacent, which is 2. So our question mark is going to be 2 times tangent pi over 3. And that is 2 square root of 3. And now I want to find this length. How can I do so? I know that this green length is 2 square root of 3, and we also know that this is 2. Let's subtract one from the other. So we will get 2 square root of 3, take away 2. Now I want to redraw this triangle somewhere here. That's the unknown angle. We know that this side is 2 square root of 3 minus 2, and here is 3. Again, that's the adjacent side, and this one is opposite. So to find the angle, let's use the inverse tangent of opposite over adjacent. Calculate it, and we'll get 0.454, correct to 3 decimal places. But please notice that for the final answer, we should give it with a negative sign, because it actually goes below the real axis. Okay, next question. Let's prepare for long division. First of all, I will have to multiply x squared by 2x squared, so I can get 2x to the power 4. Now let's multiply, and get 2x to the power 4 minus 2x cubed plus 2x squared. Now subtract. 2x to the power 4 will cancel out, and we will get a minus and minus will be plus 2x cubed minus 2x squared plus bx minus 1. Now I'll have to multiply x squared by a plus 2x, so I can get a plus 2x cubed. And when I do so, I will get a plus 2x cubed minus a plus 2x squared and plus a plus 2x. Now subtract, x cubed will cancel out, and for the coefficient of x squared, we'll get minus 2, minus and minus will cancel out, and get a plus 2. So all in all, this is a. There we go, ax squared. Now what about the coefficient of x? We got bx minus a plus 2 x. That will be b minus a minus 2 x. And then don't forget this minus 1. Now I will have to multiply x squared by a, so I can get ax squared. And when I do so, I will get ax squared minus ax plus a. Subtract and get b minus 2, x minus 1, and minus a. Now the question says that the remainder should be 3x plus 2. Basically that means that b minus 2 must be equal to 3. So that means b is 5. Now the term independent of x should be equal to 2, and that means that minus 1 minus a must be equal to 2. So that means a equals to negative 3. Okay, let's try the next one. Complex numbers strike back. So we're supposed to solve this equation and give the answer in the form z equals to x plus iy. And we also know that z conjugate looks like x minus iy. Let's substitute both into the equation. Now, I want to do two things. I want to multiply the fraction by complex conjugate, basically 1 minus 2i, so I can get rid of complex numbers in the denominator. And I can do so using the formula a plus b times a minus b would be a squared minus b squared, and we also know that I squared should be equal to -1. So using these two facts, we get 1 plus 4 in the denominator, which is 5. And 5 on top and 5 at the bottom very nicely cancel out. Okay, now using the same two facts, we know that these two brackets will multiply to get x squared plus y squared. Okay, now expand all brackets. Now, since we know that the left-hand side must be equal to 0, we could say that the real part must be equal to 0. So everything without I, x plus 2i minus x squared minus y squared plus 30 must be equal to 0. And our imaginary part must be also 0, so everything with I combined together. So now we got simultaneous equations, and I want to make y the subject from this one. Substitute it to the top equation, here and here. Again, expand the brackets. Now let's start combining the like terms. X and 4x will be 5x. And combine the remaining like terms. Let's divide both sides by -5. And solve the quadratic equation. Let's do it by factorizing. Two numbers multiply to positive 18 and their sum is -9. Guess the numbers. -3 and -6. So that means that x is either 3 or 6. Now let's find the value of y. 2x minus 10. That means if x is 3, then y would be -4. If x is 6, then y equals to 2. And combine all of these to the final answer. Okay, done. Parametric differentiation is next. How do we find dy over dx? From our equations, we can find dy over dt. But then to get dy over dx, we'll have to multiply by dt over dx. Let's start with the first one, dy dt. That's very simple, 2t plus 1. Next, let's do dx dt. That is going to be the product rule, u derivative v plus v derivative u. Let's say u is going to be t, v is going to be e to the power of 2t. So first term, t derivative is 1 times v, get e to the power of 2t. Next, plus derivative of e to the power of 2t is going to be e to the power of 2t times 2, because of the chain rule, and multiply by u, which is t. Next step, let's take e to the power of 2t out. And in our formula, we actually have dt over dx. So let's flip it over. And finally, we are ready. dy dx equals to 2t plus 1, that's our dy dt, then multiply by 1 over e to the power of 2t, 1 plus 2t. Cancel out common factor, 2t plus 1, and get 1 over e to the power of 2t. Let's write it as e to the power of minus 2t. That's exactly what we had to show. In question B, we're going to find the equation of the normal. Now we know that the derivative of our function is e to the power of minus 2t, and we're given that t is negative 1. So if I substitute t equals to negative 1 into the derivative, I will get the gradient of tangent. And that is e to the power of 2. Now, how do I get the gradient of a normal? We know that when two lines are perpendicular, the gradient of the second line is going to be minus 1 over the first one. So that will be minus 1 over e squared. Therefore, the equation of the normal would be y equals to minus 1 over e squared x plus c. How can we find c? First of all, we should find a point that belongs to this line. And since we're given the equations for x and y and the value of t, we can easily get it from there. Substitute it into x, and I will get minus e to the power of negative 2. Substitute into y, and get 1 minus 1 plus 3, which is just 3. So now actually substitute into the normal. That's my minus e to the power of minus 2. Minus and minus will be plus, so it's 1 over e to the power of 4 plus c. So therefore, c is 3 minus 1 over e to the power of 4. Now back into the equation of the normal. To get y equals to minus 1 over e squared x plus 3 minus 1 over e to the power of 4. Now we're supposed to show that the normal goes through the point with the x-coordinate of 0. So let's substitute x is 0. And we'll get 3 minus 1 over e to the power of 4. That's exactly what we had to show. Next is trigonometry, and the trick in this question is to take out the square root of 5 squared plus 12 squared out of the brackets. So we'll get 5 over the square root. 5 squared plus 12 squared will be 169, and the square root of 169 is 13. Sin theta plus 12 over 13 cosine theta. Now let's expand cosine theta minus alpha. It's going to be this expression, cos theta cos alpha, plus sin theta sin alpha. Now compare the two expressions. Next to sine theta in the first expression, that's 5 over 13. And next to sine theta in the second expression, that's sine alpha. So that means sine alpha must be equal to 5 over 13. Find alpha. (0.395) correct to 3 significant figures. So that means we can rewrite our expression as 13 cosine theta minus 0.395. Okay, question B is next, and notice how we have 2x instead of theta. Using our previous question, we can rewrite this expression on the left-hand side as 13 cosine 2x minus 0.395, and that equals to 6. Now let's divide both sides by 13. Then take the inverse cosine, so we'll get 2x minus 0.395 equals to 1.091, let's say 1. And straight after we do inverse cosine, we can find the second value of 2x minus 0.395. And in case of cosine, we could do 2 pi minus the first one. And that will be 5.1921. Now let's solve both equations for x. And let's move on to this one. Okay, and let's put this in the final answer. Right, question 7, again about trigonometry. So the major sector is here. And we know that the area of the major sector is 3 times the shaded. First of all, how can we find the area of the major sector? There's a formula, r squared over 2 times the angle. Now, which angle do we need? The large one, the reflex. And in radians, it's going to be 2 pi minus x. So we can already put it down to the left-hand side, r squared over 2 times 2 pi minus x. Now, what about the shaded area? We can do the area of the sector minus the area of a triangle. The area of a sector is going to be r squared over 2 times the angle. And for the triangle, we could use the formula half AB sine C. A half r times r is going to be r squared sine of the angle. And let's put this to the right-hand side of our equation. Now let's expand the brackets. Now what can we do? Let's multiply everything by 2 to get rid of fractions, and divide by r squared for obvious reason. Let's move this x to the right-hand side. Now sine x will go to the left to get 3 sine x plus 2 pi equals to 4x. In the last step, let's divide both sides by 4 to get 3 over 4. sin x plus 2 pi divided by 4 is going to be pi over 2. So exactly what we had to show. Okay, next one, show by calculation that the root is in between 2 and 2.5. To do so, let's substitute both of the values. We get 2 on the left, and on the right we get 3 over 4 sine 2 plus pi over 2, calculated, 2.25. And 2 seems to be less than 2.25. Now substitute x is 2.5, get 2.5. And on the right, I got 2.02. Now checking on that, 2.5 is bigger than 2.02. So now here's the logic. When x is equal to 2, left-hand side is smaller than the right-hand side. When x equals to 2.5, a left-hand side is bigger than the right-hand side. So that means that somewhere in between 2 and 2.5, they must be equal to each other. And we can write it as such. Change of the inequality sign indicates the presence of the root. Question C is about the iterative formula, and that formula is going to be xn plus 1 equals to 3 over 4 sine xn plus pi over 2. Now let's draw the table of values. Xn plus 1, no, actually xn, and xn plus 1. Now, since we know that the root of the equation is in between 2 and 2.5, we can choose any number in between those two. Let's say 2.1. Now we substitute it into the formula for xn plus 1. Okay, that's what I got. And now that goes to xn. And we repeat the process. And finally, I got the result, which is the same, correct to 2 decimal places. That means I got the answer. 2.18. Of course, your actual calculations could be different depending on your initial value of x, but nevertheless, our final answer should be the same, 2.18. Right, next question, some calculus. First, find the exact coordinates of point M, which is the minimum on this curve. What do we know about the minimum? It's a stationary point, so therefore derivative at this point must be equal to 0. So let's differentiate this. I'm going to use the product rule, u derivative v plus v derivative u. Derivative of x cubed is going to be 3x squared times v log x. Plus derivative of log x is 1 over x, multiplied by u, which is x cubed. Now let's simplify it. and make it equals to 0. Now to solve this equation, we can bring x squared out of the bracket so that our equation splits into two. X squared equals to 0, therefore x is 0, or 3 log x plus 1 is 0. Let's solve it. Now x is e to the power of negative third. But looking for the exact coordinates, so that means I'm not going to substitute it in the calculator, but I will substitute it into the value of y, which is x cubed log x. And I will get e to the power of negative 1 times log e to the power of negative third is going to be minus 1 over 3. Combine it together, and get minus 1 over 3e. That's my answer. Alright, next question is integration. So first we'll have to find the x-coordinate of that point. That's basically where y equals to 0. So let's solve the equation x cubed log x is 0. That splits into x cubed equals to 0, or log x is 0. So from here, x is equals to e to the power of 0, which is equals to 1. Now, how do we find the area? That's integration from 102 to 1 of x cubed log x. And we can find this integral by integration by parts. The integral of u derivative v equals to u v minus the integral and switch the derivative v derivative u. Now we'll have to choose our functions u and v, and the best thing to do is to choose v in such a way that the derivative is easier than the actual v. So I will make log x v and x cubed u derivative. Now, since u derivative is x cubed, I'll have to integrate it to find u. That will be x to the power 4 over 4. Now the derivative of log is 1 over x. So all in all, our integral becomes u times v, x to the power 4 over 4, times log x. That's my u v, and I'll have to evaluate it from 1 over 2 to 1, then minus integral of v derivative u. That's 1 over x times x to the power 4 over 4 dx. Now let's substitute our upper and lower limits into x to the power 4 over 4 log x. And also simplify our integral a little bit. Now we know that log 1 is 0, and it has to be exact area, so that means I'm not going to substitute log 1 over 2 into the calculator. Instead, I will do 1 over 4. 0.5 to the power of 4 would be 1 over 16. and integrate x cubed, which is x to the power 4 over 4. Now we got minus 1 over 64 natural log half minus 1 over 16 again, x to the power 4 from 102 to 1. Now substitute upper and lower limits into x to the power 4, and we'll get 1 minus 1 over 2 to the power 4, which is 16, so that. And all in all, I got minus 1 over 64, natural log half, minus 15 over 256. Now, this doesn't look really nice, because a lot of minus signs, so I'll represent log 1 over 2 as log 2 to the power of negative 1. And I'll bring the minus 1 out. And I think that looks way much better. But let's not rush and write it as the final answer. Why? Because if you look at this curve, then it lies below the x-axis. So that means that the integral is going to be negative, but the area should be positive. So what I'm going to do is to multiply my answer by negative 1 to make it positive. So 15 over 256 minus 1 over 64 times log 2. Okay, question 9. Differential equations. First of all, I'm going to multiply both sides by dx. And then I will divide by e to the power of 3y. Congratulations, we just separated the variables. Now that means we can integrate both sides. Now the one with e is pretty easy. The one with sine squared is quite difficult. So what we can do in this case is to remember that we actually have the double angle formula for cosine, which looks like 1 minus 2 sine squared a. Now, if you actually have cosine 4x, then that will be 1 minus 2 sine squared 2x. Because notice how the angle on the left-hand side is the double of the one on the right-hand side. That's why it's called the double angle formula. And now using this formula, we can rearrange it and make sine squared 2x the subject. And substitute it into our integral. Now, integral of 1 over 2 is going to be x over 2. Now, the integral of cosine is going to be sine 4x times 1 over 4. And of course, do not forget to add c. Now, we're given that y equals to 0 when x is 0, and that will help us to find c. On the right-hand side, everything equals to 0 apart from c. So that means c equals to minus 1 over 3. Now we have to find y when x is a half. Do we have to find the exact value? No. Okay. So that's what I got for the right-hand side, and I'm going to multiply everything by -3. E to the power of minus 3y equals to 0.591. Next, take the natural log of both sides and divide by -3 to get y. (0.175). Question 10 comes next, and that's about vectors. Two vectors, OA and OB, and we have to find the obtuse angle between them. So for that we have the dot product. We know that OA dot OB should be equal to the magnitude of OA times the magnitude of OB times cosine of the angle in between them. Now let's find the magnitude of OA. 9 plus 1 plus 4, the square root of 14. The magnitude of OB, 1 plus 4 plus 9. Also 14, what a coincidence. Now we can also find the dot product using the coordinates. x1 times x2 plus y1 times y2 plus z1 z2. So we'll get 3 minus 2 minus 6, which is -5. Now let's substitute square root of 14 here and here. We'll get 14 cosine theta. Now, since both expressions are the dot products of the same vectors, we could say 14 cos theta equals to -5. Now take the inverse cosine and get 110.9 degrees. Okay, in the next question we will have to find the equation of the line that goes through points A and B. And for that we'll first have to get on a line, and we could use any of the vectors OA or AB. I will use OA plus some number, I will call it lambda, multiplied by the direction vector of this line, I will call it AB. So the vector OA is going to be 3 minus 1, 2, plus lambda. And now we have to find the vector AB, and for that we'll have to subtract coordinates of A from B. 1 minus 3 is going to be -2. 2 minus -1 is 3. And -3 minus -2 will be -5. Or we can write it in this form. 3i minus j plus 2k plus lambda. And we can change the direction of vector AB. So it's 2i minus 3j then plus 5k. For question C, first we'll have to find the equation of the line CD. And it's a very similar process to the previous question. First we need to get on a line, and I will use the vector OC, which is 1, -2 and 5. Plus some number, I will call it mu, multiplied by the vector CD, which is 4, -4 and 6. So this is the line CD. Now from the previous question, the line L is 3 minus 1, 2, plus lambda, 2, minus 3, and 5. That's the line L. Now, given that the two lines intersect, we could say that the x-coordinate should be given by the equation y plus 4 mu equals to 3 plus 2 lambda. The y-coordinate is minus 2 minus 4 mu equals to minus 1 minus 3 lambda. And for z-coordinate, we got 5 plus 6 mu equals to 2 plus 5 lambda. Now we know that the two lines intersect for sure, so I will only consider the first two equations. Now let's simplify them and collect the like terms. We will get 4 mu minus 2 lambda equals to 2, and minus 4 mu plus 3 lambda equals to 1. Let's add up these equations term by term. And we'll get lambda equals to 3. Now substitute it into the first equation and get 4 mu minus 6 equals to 2. And from there we can get mu equals to 2. Now let's substitute those lambda and mu into our equations for x, y, and z coordinates. For x coordinate, I will get 1 plus 4 mu, and that is 9. For the y coordinate, it's minus 2 minus 4 mu, minus 10, and for z coordinate, 5 plus 6 mu will give us 5 plus 12, which is 17. And our answer should be the position vector of the point of the intersection. Which is 9, minus 10, 17. That's it. Next question is about partial fractions, and first of all we'll have to look at the denominator. And we'll see that we have two factors there. The first one is what we call an unfactorizable quadratics. And the second one is a linear factor. Now we know that the unfactorizable quadratics will give us a partial fraction in the form ax plus b over the actual quadratics. And a linear factor would be c over 1 plus x. Now let's try to combine these fractions together. And now consider only the numerator of this fraction and that one. Since they must be equal for any x, we're free to substitute any convenient values of x. And the first one will be minus 1. Why? Because this way I can cancel out this term. If I substitute x equals to minus 1, I will get 5 minus 1 plus 11 on the left-hand side. And on the right-hand side, I will get 0 plus 5c. So therefore, c equals to 3. Now, I want to cancel out a, so I can substitute x equals to 0. And on the left side, I will get 11. On the right side, there will be b plus, we know that c equals to 3 times 4. So therefore, if we solve it for b, we get minus 1. Okay, and now I'll substitute just any value of x, let's say x equals to 1. And let's solve this equation and find a. Now that we got our a, b, and c, we can write the final answer. Move on to the next one. And here goes the last question. We'll have to integrate from 0 to 2 our previous expression. Now let me split the first fraction into 2. And now we have to combine a few techniques for integration. The first fraction. We will have to use the fact that the integral of f derivative over f would be a natural log of modulus f. For the second one, and you can find this formula in the formula sheet, it's 1 over x squared plus a squared would be 1 over a inverse tangent of x over a. Now for the first fraction, if we check the derivative of 4 plus x squared, that's going to be 2x, which is exactly the numerator of this fraction. So we know that the first integral is going to be natural log of 4 plus x squared from 0 to 2 minus. Now for the first fraction, you'll have to notice that 4 equals to 2 squared. So the integral is going to be minus 1 over 2 inverse tangent x over 2 from 0 to 2. And the last fraction is the easiest, that is 3 natural log modulus 1 plus x from 0 to 2. Now we're going to substitute upper limits and the lower limits. I prefer to keep a bracket. First of all, the inverse tangent of 0 is going to be 0. Natural log of 1 is also 0. Now we can combine these two logs together. It's going to be a natural log of 8 divided by 4, which is 2. The inverse tangent of 1 is pi over 4. So that will be pi over 8. And then 3 natural log 3. Now let's bring the number next to log into the power. Three cubed is 27. Combine these two together, that will be a log of a product. 2 times 27, that is 54. And that was what we were supposed to show. Okay, that was the last question of this paper. Hope you found it useful. And if you're taking the exam on Wednesday, I wish you best of luck. I hope to see you next time. Bye bye.